Guys, I'm going to go through Regents Prep 2 now. Number 1, we start with our short constructive response questions. So we're going to base it on the chemical equation. How does the balanced chemical equation show the law of conservation of mass? Well, the law of conservation of mass is I have to have the same number of atoms on each side because I have to have the same number of mass on each side. So the fact that the equation is balanced is really good. I would go with the same number of atoms on both sides. Something like that. The mass is going to be the same if I'm going to have the same number of atoms. So number 2. What is the total number of moles O2 produced when 8 moles of H2O are completely consumed? So they want to know about my moles O2, so that's my X. They want to know about that. And they want to know when I have 8 moles of H2O, so 8. So I'm going to basically set up in a ratio and solve for it. So originally I had 2 moles of H2O, but now I have 8. And I'm going to set that equal to, originally I had, there's nothing in front of it, so 1 mole of O2. And now it's X, I want to see. So I'm going to cross multiply to solve. So I get 2X equals 8. So I'm going to solve by divided by 2. So X equals 4. And that would be 4 moles. And they asked about O2. 4 moles O2. Set up a ratio. Number 3, show a correct numerical setup for calculating the number of moles MgOH2, and they give me the gram formula mass, so that's nice. They want me to use that if they give it to me, in an 8.4 gram sample. So I wanted to do the moles. So I would think, okay, I'm going to go to my reference table T, and I'm going to figure out, well, what's my mole equation? Moles right here is moles equals given mass over gram formula mass. So it's okay. Moles equal, given mass was my 8.40, gram formula mass was my 58, right over here, 58.3, and they just wanted the numerical setup, so that's my answer. Technically I could put my units on there. I wanted to be a little good egg, but they would accept it with just the numbers. Okay, 4. If a person produces 0.5 moles of excess HCl in the stomach, how many moles of MgOH2 are needed to neutralize this excess hydrochloric acid? So I'm going to say, okay, go up here. Instead of 2 moles of HCl, I have 0.050 moles. And they want to know, well, then how much would neutralize it? So X. So set up a ratio again. 2 over 0.05 equals 1 over X. So I get 2X equals 0.025. So that's going to give me my X, which is going to be equal to 0.025. And now that's moles of MgOH2. Brand B in acid contains the acid neutralizing agent sodium hydrogen carbonate. Write the chemical formula for sodium hydrogen carbonate. So I'm think, okay, the chemical formula, I have to look up, well, what the heck's sodium and what's hydrogen carbonate? Well, sodium is Na, and it has a +1 oxidation state. Hydrogen carbonate is actually something I would find on table E, because it is a polyatomic ion. So if I go to my table E, I'm going to flip there. I'm going to say, okay, I'm looking for hydrogen carbonate. HCO3 minus. So hydrogen carbonate is a polyatomic ion. HCO3 minus. Crisscross that, so they're -1, so they're both 1s. So I'm going to get NaHCO3. sodium hydrogen carbonate. 6. What is the mass of 4.76 moles of Na3PO4? And they give me the gram formula mass. So they gave me my moles. They want my mass. So I'm going to use my mole equation again. I remember that was moles equals my given mass over my gram formula. So given mass over my GFM. I'm going to say, okay, I know my moles. My moles was 4.76. And that equals my given mass. I don't know. They want my mass. But I know my gram formula mass was 164. So I'm going to solve for that x. So I'm going to multiply by 164 to get that out of the denominator. And I'm going to get x is equal to 780.64 grams. 780.64. There, I wrote it a little better there. Grams. 7. Determine the percent composition by mass of oxygen in the compound C6H12O6. So I want to do, okay, percent composition by mass, and I'm doing it of oxygen. So I can grab that off of my table T. Percent composition by mass is mass of the part over mass of the whole times 100. So my mass of the part, my mass of oxygen, I want to think, why not 6 oxygens? So oxygen is 6 times the mass is 16. And then I'm going to go ahead and say, okay, that's 96. So my oxygen has a mass of 96. And then the mass of the whole thing, well, I got to add everything up. So I have 6 carbons that all have a mass of 12. So 6 times 12. Plus hydrogen, I have 12 of them, and they have a mass of 1. Plus the 6 times 16, because those are my oxygens. That's going to add up to be 180 grams. So go ahead and do my percent. I'll do it over here. My percent composition, I'm going to have my part, 96, over my whole, 180, times 100. Don't forget that times 100. So if I do that, I'm going to get 53.3%. percent. 53.3. So for the next question, they give me a reading, and then I'm going to base my answer to question 8 on that reading. So I'm going to actually go to question 8 and see what they're asking. So question 8 says, determine the total number of moles CH3Br in 19 grams of CH3Br, and they give me the gram formula mass. So again, they just want me to use the mole equation. So I'm going to table T. I'm going to say, okay, well, my moles is my given mass, which was 19, over my gram formula, which is 95, which is going to give me the answer of 0.2. 0.2 moles. Okay. So it says, number 9, when heated, a 0.1250 gram kilogram sample of arsenopyrite yields 67.5 kilograms of FeS. Determine the total mass of arsenic produced. So I want to think, well, what was the arsenopyrite? So I look over here and I say, okay, well, that must be that, because I don't know what that is. And I know that I have 67.5 kilograms of this. So 67.5 kilograms. I had 125 kilograms of that. And I want to know, well, how much do I have of that arsenic? So something plus 67.5 has to equal 125 kilograms. This is law of conservation of mass. So let's just solve for that question mark, basically. So from 125, subtract 67.5. 125 minus 67.5. And I'm going to get 57.5 grams. 57.5 grams. Again, if you're going to explain this, this is law of conservation of mass. I cannot create or destroy mass. So I start with, I have to end with. Key number 10, calculate the percent composition of mass, arsenic, and arsenopyrite. Your response must include both numerical setup and the calculated result. So that's what's important. I need both the setup and the result, so I'll make sure I do both. Percent composition, again, I'm going to do the percent composition formula. Mass of the part over mass of the whole times 100. So I would say, okay, I had my mass of the whole. Let's get my mass of FeAS, and I'm going to say, okay, well, that has a mass of 56 is Fe, arsenic is 75, sulfur is 32. That gives me 132 for my, I'm sorry, not 132. No, I can't add. 163. 163 grams, that's my whole. And my part was just, well, that, your arsenic was 75. So, I'll do it over here. I have some more room. So my percent equals 75 over 163 times 100. It would be wrong if we didn't put that times 100. And if I do that, I'm going to get about 46%. Just remember you need to do both. 11. Write the formula for the compound produced when arsenic is heated rapidly in air. So when it was heated, I want to think, well, here's my product, my FeS. So I just want to know how to name that. So the only thing I want to be careful of is that Fe, if I go to my reference table, we're going to have multiple oxidation states. Let's find that there. I could be a +2 or a +3. So I'm actually going to check out sulfur and see that sulfur, the top number, is -2. So if sulfur, so it was FeS, right? So I'm going to write this out. FeS. So that means if sulfur was -2, then Fe would have to be the +2. So I'm going to do a Roman numeral since it says multiple oxidation states. So we say, okay, Fe is iron, so iron. 2, because that's my oxidation state, +2. And then sulfur, but I have to change the ending, so sulfide. Iron 2 sulfide. 12. The empirical formula of naphthalene C5H4, so empirical, and the molecular mass is 128. What is the molecular formula? So remember, molecular formula is not simplified, and the empirical formula is simplified. So if I know that simplified C5H4 and total it's 128, I'm going to see what the mass of the C5H4 is. So C5H4, I would do 12 is the mass of carbon times 5, plus 1 is the mass of H, and I have 4 of them. So 12 times 5 is going to get me 64. And so I'm going to go ahead and I'm going to figure out, okay, well, 128 divided by 64, because that's the mass of the unsimplified. That's simplified. I'm going to get 2. So 2, I'm going to go 2 times that C5H4. I'm going to distribute it. So I get C10H8. C10H8. 13. Determine the number of moles of SN liquid produced when 4 moles of H2 is completely consumed. So they want moles of SN, so that's X, and they're telling you have 4 moles of this H2. So I'm going to set up my ratio again. So remember, originally I had 2 moles of H2. Now all of a sudden I have 4. And I originally had 1 of SN. And now I have X. So I solve for X, cross multiply. 2x equals 4. So that means X equals 2. That's your answer, 2 moles of SN. Easy peasy. Okay, question 14. Says, calculate the gram formula mass of glycine. Your response must include both the numerical setup and the calculated result. So in the reading, I would say that glycine is this NH2CH2COOH. So that's kind of the important piece is I'm looking there. And I'm just going to look up the masses of everything and I'm going to add them together. So nitrogen has a mass of 14. You have one of them. Hydrogen has a mass of 1. Let's see total. I have 2. Another 2 is 4, and another 1 is 5, so I have 1 times 5. Plus I have, let's see, my carbons. I have 2 carbons, so 12 times 2. Plus I have 2 oxygens, so 16 times 2. There's my numerical setup. I'm going to see, I'm going to plug that into my calculator, and when I do that, let's see. I get 75. So 75 grams. Or grams per mole, either unit. Almost there with the short answer. So 15 says determine the gram formula mass of the product. So I'm going to say, okay, I know that this is my product. So I'm going to just kind of rewrite it all together. I have, let's see, I have 1 C. I have, let's see, 2 N's, I have 1 O, and I have 4 H's. So H4. And if they want the gram formula mass, I'm going to add that together. So I'm going to do 12 times 1 plus 14 times 2 plus 16 plus 1 times 4. So I'm getting those masses from my reference table. And that's all going to add up to be 60. So the gram formula mass of this urea is 60 grams, or 60 grams per mole. 16 says write the empirical formula of the product. Well, if I'm looking, I can't really simplify this any further. So otherwise, I can simplify my N's and my H's, but I can't simplify my C's or my O's. So I'm just going to write exactly what I had. CN2OH4. And honestly, it really does not matter the order that your atoms are in. And then it says, explain why this balanced equation represents the conservation of atoms. You had a question like that earlier. Conservation of mass because you have the same number of atoms on both sides. You might not word it that way, but something like that. Same number of atoms on both sides. 18. Show the numerical setup for calculating the number of moles of SNO2 in a 3-gram sample. So I want moles. They tell me I have 3 grams. Up here, if they told me my gram formula mass of this SNO2 was 151, so they're trying to help me out here. So moles, remember, I go to my table T. It's your given mass over your gram formula mass. So you have 3.0 grams over gram formula mass was 151 grams per mole. And that is going to give me, let's see. Oh, wait. I only need the setup. That's all you needed. Boom. 3 over 151. Solve it if you want, but you don't have to. All right. I think it's, let's see, 2 more. Yep, 2 more of our short answer. So they give me a lot of reading here. I do want to check this out, and I should pay attention to I have data here. So I'm going to assume you read that. And it says using the student data. Ooh, that's important. The student data. So look up here. Show the how the numerical setup for determining the mass of water and the hydrate. So I want to do the percent mass of water. I know that I have, let's see here, 0.76 grams of water, and my mass of the whole would be right here. So here's my whole, and here's my part, because this is the hydrate with the water, and this is just the water. So numerical setup, I'm going to go percent. equals 0.76 over 2.13, but don't forget your times 100. And there you go. Your percent composition by mass can be found on your reference table, Table T. And 20. Explain why the crucible containing the sample must be heated until a constant mass is reached. If you remember from this lab, what I'm trying to do is I'm trying to get rid of the water on the hydrate. So if I don't wait until I have a constant mass, I might miss some of that. So I want to make sure all the water evaporated. So make sure all water evaporated. Or say you want to get all the water out, whatever. Either way, just make sure all the water is gone. That's why I want the constant mass. All right, so we are now moving on to our multiple choice, which means we're actually getting close because there's less multiple choice than there was your answer. So 21. All chemical reactions have a conservation of, well, there's three things that are always conserved: mass, charge, and energy. Remember, if you kind of take those, the CH, the E, and the M, it spells chem. Is always conserved. So, choice 4, mass, charge, energy. 22. This reaction is classified as, let's see, I have two compounds. It's still two compounds, but it looks like the Ag and the Na switched. So, double replacement. Two things switch. (23) Which compound is represented by X? So I just want to make sure that I conserve my atoms. So I have 4 Fe's here and I have 6 O's, but just make sure you have it times 2. So if I have 2 Fe's, Fe2 and O3, if I multiply that by 2, I have 4 Fe's. I'd have my 6 O's. So like that, Fe2O3, just 2. Conserve your atoms. 24. Which equation represents a double replacement? Again, I want two things to switch. So I'm going to look for all compounds. So I like choice 3. Little 2's hanging out there. Shouldn't be there. But I like that I have those compounds. So think all compounds when you do a double replacement and two things switch. 5. The compound is made up of iron and oxygen. The ratio of iron ions to oxide ions is 2 to 3. That's the important part, but that's the ratio. The IUPAC name for this compound is, so if it's 2 to 3, that means it's Fe2O3. So if I'm thinking, well, what's the actual name of it? I'd reverse my crisscross to actually get my oxidation state. So that means Fe is plus 3 and O is minus 2. I just want to kind of double check that that makes sense. If I go to my reference table, I would see that O does like to be minus 2, so that works out. So, Fe is plus 3, so I want choice 3, iron 3, oxide. I gotta give that Roman numeral for my iron. 26. Given the balanced equation, what is the mole ratio of CO to CO2? So if I see CO, there's 2, CO2, there's 2. So really I would say it's 2 to 2 for my mole ratio, but I can simplify that. I don't see a 2 to 2, so I'll pick instead choice 1, 1 to 1. 27. A compound has a molar mass of 90, an empirical formula of CH2O. What's the molecular formula? So your empirical is your simplified, and that's the molar mass, so that's your molecular mass. So your non-simplified mass. So take that 90. Well, actually, first let's figure out what that is. So the mass of that is 12 plus 1 times 2 plus 16. That would be 28, 30. So if I go 90 divided by 30, I'm going to get 3. So I got 3 times CH2O. So C3H6O3. There's 3. 28, what is the percent composition by mass of hydrogen in the formula? And they do give me the gram formula mass, so I just want to figure out, well, how many hydrogens? I have 5, so 4 here and 1 there. So 1 times 5 is 5. So your percent, your part is 5, your whole is at 79. Don't forget your times 100. So you're going to get for that one that your percent, we just have to plug it in. And 28 is going to be 6.3. Here's 2. 29, which equation represents a decomposition? So decomposition, I want to think breakdown. So if I break down, I need to start with one thing and get more things. So I immediately like bad copies, but I like choice 1. I start with 1, I break down into 2. 30, a compound has an empirical formula of CH2O, which actually we just use it up there. That had a mass of 30 grams. And a gram formula of 60 grams per mole. What's the molecular formula? So same thing, do your 60 divided by your 30. You're going to get 2. So you're going to do 2 times CH2O. So C2, H4, O2, choice 2. 31. The percent composition by mass of nitrogen and NH4OH, the gram formula mass is 35 grams per mole, is equal to. So percent composition by mass, I'm going to think I'm going to my table T again. And I know that that's your part over your whole and times 100. So the mass of nitrogen, well, there's 1 nitrogen, so that would have a mass of 14. So really, that's the only one that makes sense. 14 over 35, so part over whole times 100. I like choice 2. Okay. Almost. 38. Given the balanced equation representing a reaction, I have 1,170 gram sample of NaCl. So I'm going to note that. I have 1,170 grams of that. And it completely reacts, producing 460 grams of Na. So 460 grams of that. And they want to know the total mass of Cl. So how much of that? So, well, conservation of mass, this side has to equal this side. So 1170 has to equal 460 plus something. So what the heck is that something? We'll solve for it. Subtract 460 from this. And so I'm going to get the answer to 32 is going to be choice 2. 710 grams. 33. What is the ratio of moles of CO2 produced to moles of C2H6 consumed? So just go up and look at their coefficients. So CO2 is a 4. C2H2 has a 2. So I would say it is 4 to 2, which is the same thing as saying 2 to 1. So, choice 2. I'm going to try to trick you by simplifying it. Don't let that trick you. 34. What is the total number of moles CO2 produced by the complete combustion of 5 moles of C2H6? So I'm going to have 5 moles of that, and I want to know how much O2, so let's do a ratio. Originally I had 2 moles of the C2H6, now I have 5, so 2 over 5 equals originally I had 4, but now I have X. So I'm going to solve for that, so I'm going to get 2X equals 20. So therefore, X equals 10. Answer is choice 4. 35. A hydrate is a compound with water molecules incorporated in its crystal structure. An experiment to find the percent by mass water in a hydrated compound. The following data was recorded. What is the percent by mass water in the hydrate? Okay, so I want water in my hydrate. My crucible and my hydrate was 7.50. But just my crucible was 6.9. So if I take these, I'm going to get just my hydrate. So my hydrate mass was really 7.50 minus 6.9. So I'm going to get 0.6. And then my mass of my crucible and my anhydrous, so without water. So I'm going to write anhydrous. Anhydrous is 7.2 minus your 6.9. So water without water. 7.2 minus 6.9, 0.3. So in order to get my water, I actually have to subtract those. So 0.6 minus 0.3 is going to get me 0.3 as my water. That's my part. And this hydrate is everything. So this 0.6 is my whole. So my percent is my part was 0.3 over 0.6 times 100. Choice 2, 50%. This one actually involved more work than it looks like. If they give you lab data, you're going to have to figure that out, just like your percent composition in a hydrate lab that you did. 2 more, no, 3 more. 36, which pair consists of a molecular formula and its corresponding empirical? So think empirical means it's simplified. And molecular, well, not simplified. So I want to make sure they simplified correctly. So C2H2, now I have C2H6. Nope. C6H6, now I have C2H2. I think that could be right. SO2 over SO3, no. P4O10, P2O5. Ooh, I like that too. So what's the difference? Ooh, I can simplify that further. C2H2 can be just CH. So I could simplify. So that's not the answer. It is choice 3. That is correctly simplified. Your P4O10 turns into P2O5. 37. On which compound is the percent by mass of oxygen the greatest? So what you want to do for this one is you actually really want to figure it out. So what I can look at is my gram formula mass, because your percent by mass oxygen, that's going to be, remember, percent by mass is your part over your whole. So really what I want to think is my part is always going to be oxygen, which is going to be 16, but my whole, I'm going to add these together. So what I really want this to have, if it's the greatest percent by mass, I want the lowest gram formula mass. I have to figure that out for each one. So if I figure out my gram formula mass, 1, that's the lowest. If you don't trust me, go right to your reference table. And in fact, if you're correcting this, prove that to me. 38. Last one. What is the total number of moles O2? I don't know. Make that X. What must react completely with 5 moles of C4H10. So 5 of that. So let's go ahead and let's set up a ratio. Originally it was 2, now it's 5. Equals originally it was 13. Now it's X. So 2X equals 5 times 13, which is 65. So that means X is 32.5, which is choice 4. Great job, guys. This was another long one. Most of the other ones are a little bit shorter. You're doing great if you're watching these videos. I hope they're helping, and you're going to do awesome on the Regents. All right, bye, guys.